Hello everyone. Today we are going to build an intelligent AI knowledge worker from scratch with live coding. This system will work for any company. I will show you how to use RAG, Retrieval Augmented Generation, to create an accurate and cost-effective AI assistant. Let's get started. Expert knowledge worker. Here in this embedding folder, here I define my knowledge base for company details, employees, and product details. Okay, let's get started. Let's import our libraries. Import OS, import glob from .env, import load.env. These are basic imports for file handling. Import Gradio for UI, SGR. Now import LangChain components for RAG. From LangChain community, import. Not we use LangChain, so we need to import chat OpenAI, not OpenAI. Chat OpenAI, and for embeddings, OpenAI embeddings. Let's run. Okay. Now let's set up our configuration. Here I am making a important decision like defining model. Model equals to GPT-4 Omni. DB name equals vector DB. Okay, now run. See, I am using GPT-4 Mini, not GPT-4. Why? Because in the real world, cost matter. If you have a company, you need to consider budget. This model give 90% accurate result and 10% of the cost. Okay. Now set up our environment variables. Load.env. Let's verify. Okay, now run this cell. Perfect. Now I am loading my documents in my project. Okay, let's get started. Folders equals to glob knowledge base slash star print f found folders folder print करा लेते हैं. Okay, text loaders quarks equals to encoding UTF-8. Yes, documents equals to array for folder in folder. The type is equals to os dot path base name equals to folder. Loan directory loader folder comma globe equals to star star slash star markdown formats because our all file in markdown format. Class is equals to text loader class is equals to text loader class. Okay. Folder docs is equals to loader dot load. For each doc in folder doc doc dot metadata doc type हम metadata के अंदर doc type सेट कर देंगे doc type. Okay. Documents dot append doc. Let's print f length of documents. Yes, 31 documents from 4 folders. Go to next cell. Now I will demonstrate text chunking. This is a very important step. Text splitter is just character text splitter chunk size. Here I define my chunk size 1000 and chunk overlap. In our vector DB, we store data in the form of chunks. Chunks is equals to text splitter. Where to split documents. Let's run this cell. Created a chunk of size 108088 which is longer than specified 8000. Okay, no problem. See, the text automatically gets divided into chunk. We keep overlap so the text context does not get lost. Let's print the length of our chunks 123. Now the most interesting part, we will create vectors. This is a real magic. First we define our embeddings open. Here we not specify model, just run embeddings. Create our vector store. Vector store equals to chroma dot from documents document to chunks comma embeddings is equals to embeddings comma persist directory is equals to our dv name. Yes, let's print f vector store created collection dot count. Now run this cell. Okay, our vectors are created. Now let's visualize our vectors. First, check collections. This is vector store dot collections. Sample embeddings collection dot get including embedding, comma embeddings. Limit is goes to 1, comma and embeddings and 0. Dimensions, length of sample embedding, bring dimension of the embeddings. Let's print dimension of the embeddings is 100. Dimension of the embeddings is 1536. But in this okay, dimension of the embedding is 1536. But for visualization, we need 2D dimensions. So we need to do some pre-work. Result collection dot get including embedding metadata vectors to np dot array result embeddings. Documents is result documents and doc type is just to metadata doc type for more type of metadata. I define colors for my plot. blue, green, red. No, no, no. This is not. Orange for products, employees, comma, contracts, comma, company dot index t for t in doc types. This is a prereq. Here I define my configuration for np is not defined. I check. Okay, I'm not import np. Let's get import numpy as np. Now run this cell. Yeah. Okay, now convert our 536 dimension to 2D dimension and visualize in a plot graph. So TSNE is equals to TSNE components to random history to. Let's import TSNE. Scikit-learn.manifold import TSNE and plotted.graph object as go. Reduced vector TSNE.transform vectors. Figure is equals to go dot data is equals to array go dot scatter x is equals to reduce vector 1 go mode marker depth color size 5 colors then no need for line type t document in type t br text dimension 100 dot doc type. Okay, hover text. Though no need for other configurations. Fig dot update layout. Title is equals to 2D Chroma vector store visualization. Scene dict x axis title is equals to x y axis title is equals to y. Width is equals to 800, height is equals to 600. So legends and mark is equals to dict r is equals to 20 left 40. Let's run this cell. Okay, forget comma invalid syntax single string dict c. Okay, comma. Yes, this is our vector data store visualization. You can see like type contract text 1 products employees and company. Here are all four types of document visualizations embedding. We can zoom out, zoom in. Let's try in 3D. Okay, TSNE is equal to TSNE, N components is equal to 3, reduce vector, TNC is equal to figure dot videos, marker dot text dot over text, figure update, margin date, figure dot. So let's run this cell. Yo. You can visualize vector store in 3D form. Each dot represent our vector in the form of 3D. Yes. Green for type employees, red for type contracts, blue for type products, and yellow for company. Okay, now test it. Now I will run live queries. First util function, util knowledge based query, comma case goes to 3 by default. Results is goes to vector store dot similarity search query and key for I results in enumerate results, printf result 1, document type, and page content. Metadata dot get doc type print on content. Okay, return results. Test query, insurance policies, employee benefits, contractual company employees. Now run this cell. Search for important insurance policies. Scroll level content. Okay. Okay. It gives me all data from my knowledge base with vector through vector DB. Now I create a simple user interface through Gradio. So let's def answer question. If not question dot questions dot stripe. Please provide a valid question. First relevant docs. I find here now I find relevant docs from my vector database through similarity search, comma k is equals to 3. Context is equals to backslash dot join doc page dot return f based on the context based based on the based on our knowledge base backslash n backslash n context colon 500. Here I will just demo you. Now create Gradio interface. Interface is goes to gr dot interface f1 answer question input Gradio text box inputs not they need for only text box. Remove this line and here for answer input output also need for gr dot text box answer will appear here. Okay, no problem. Lines is equal to 10. Okay, run the cell. Yeah, open question. I will ask my employee Carter. Okay, based on our knowledge base, Emily Carter inflicts the kind of talent that drive Insurellm success in the invaluable assets of a company. HR record, summary, date of birth. Okay, it gives me all details of Emily Carter from my knowledge base. Here I truncate my response. You can create this type of projects according to our use case. This is a demo project, so how can use vector database for our AI agent to answer query properly according to our knowledge base. This is the extension of our previous video where I use brute force approach for similarity search. Here I use vector database for similarity search. Okay, let's wrap up this video with song GPT outro. My songs playlist, AI agents, God infinity.